All right. So the junior problem, given the relation below, state the domain and range, then determine whether the relation is a function and explain your answer. All right, so the explanation part, it varies depending on which definition of function, bless you, that you liked from yesterday. Because we had really three different variations. One was a contextual one based on any background information that you might be given related to the nature of the problem. So, like if it's a word problem, basically. Right? That's not the case here, but we also learned how you can determine if something is a function based on coordinates and how they relate to one another, and then also graphically. All right. So any of those explanations are fine. You don't need all three of them. Whichever one you like the most is going to be okay. All right. But the domain, regardless of whether it's a function or not, the domain and range is something that you could determine just based off what values of x and what values of y are accounted for. All right, so here it's just the raw values, negative 4, 0, 6. And the range, the accounted values. And remember, there were some problems in the homework where you had some numbers in the range bubble that didn't have arrows drawn to them. Those would not be part of the range because they're not included in the set. All right, so we're looking at 12, 18, and 40. All right, so these are the possible values of x and the possible values of y for this would be potentially function, definitely, or relation. All right, so what we want to know is, will any of these x values correspond to more than one y value? So what do we say? Yeah, which one? 6. Okay, so 6 corresponds to both, what is that, 12 and 18? So therefore, not a function. On the regents, write out not a function. For me, NF is fine. All right, I'll know what you mean. It's my abbreviation, so I better. All right. So that's my explanation. 6 corresponds to 12 and 18. Right? So if we're looking to make a prediction from this model, I wouldn't be able to confidently make a prediction because I couldn't say if this, then definitely that. Right? It's if this, then maybe that. If there's a maybe in there, all bets are off. All right. Now, once you know something is a function, then we could represent it in what's known as function notation. Right? So this is a little, the word's not confusing, it's just different. Well, I guess it could be confusing. But this symbol here, f parentheses x, does not mean f times x. Right? It means f of x or f at x. Or the function y, typically y, not always, at a given x value. All right. It's just unfortunate that, there's only so many symbols that we could use, so some of them have to pull double duty. All right. So you have the parentheses. They mean, well, we use it for a lot of things. We use it for interval notation. We use it for coordinates. We use it for multiplication. And now we're using it to represent that f is of something. All right. So really, I would say that the parentheses here are kind of more like the way you would use parentheses if you were writing a sentence. All right. It's just kind of like a subtopic within that sentence. All right. That's the same idea here. All right. Your whole sentence is 3x plus 1. The x is the subtopic within the sentence. We're defining that x term. All right. So again, it's not the multiplication of f times x, which is something you got to be very careful about, because when a question asks you to solve for something, you might end up dividing both sides by x, thinking, well, I got to get the f alone. That's not how it works. Right? But when you're evaluating a function, it's actually pretty easy as long as you understand that that is f, the function f, when x is equal to some number. Right? So if you look at number 1, all it's really saying is I have some equation that's defined in terms of x, meaning the variable of interest is x. If they ask me to find f of 4, all it's telling me to do, it's a little recipe. All it's telling me to do is take my function and everywhere I see an x, replace it with a 4. All right. So, and again, this is new. Well, for most of us, it's new, and it's different enough that, I mean, if you don't review this, then the next time you see it, you might think, well, what the heck is this? F times 4? Because what people will do is they'll take this 3x minus 5 and multiply it by 4, because they're saying, well, it's saying f times 4, so that's my f, multiply it by 4. I guess that's what I'm supposed to do. Not at all what you're supposed to do, right? So if I were you, I'd write a little notation here saying, given function f, replace each x with a 4. All right, because ordinarily it would be f of x. It's not f of x. So given function f, replace each x that would have been there with a 4, because the x has been replaced with a 4. All right, and then once you do that, all we're going to do is simplify. So 12 minus 5 gives you a result of 7. All right, so f of 4 results in a 7. All right, and this is what I was talking about before. F of 4, that f parentheses 4 is not multiplication. So your instincts might be, well, I got to get the f alone, so let me divide both sides by 4. You don't do that, because what this is saying is function f has a value of 7 when x is equal to 4. All right, that's all it's saying. All right. The left-hand side, that f of 4, is saying, what is the value of function f when x is equal to 4? It's asking for a calculation. Now, another way to think about this is, well, we just figured out, normally we would write this as y equals 3x minus 5. So this takes the place of y. And really that notation is just telling us that we have some function that normally we would call y equals 3x minus 5. But we're going to call it f of x for brevity, for simplicity, whatever you want to say. But it's really your way of telling the reader, don't bother testing to see if this is a function. You don't have to bother with the vertical line test. You don't have to plot points. You don't have to conceptualize it. Just, it's a function. I'm telling you it's a function because I said f of x. All right? Now that you know that it's a function, you do some things with it. All right? But really, it is a y value. So when we perform these calculations, I'm replacing x with a number, and I'm getting a result that will be a y value. All right? This notation is the same as saying the coordinate 4, 7. All right. Now this, when you think of it that way, this may seem like a completely unnecessary topic, right? Because it's like, wait a minute, I'm just finding a y value given an x. We've been doing that for a long time. Why do we have to do it this way? This is the language of all the math classes that follow. So algebra 2, pre-calculus, calculus, any level of calculus, they're all going to speak in this language. All right, so there's that component. Like, if you don't understand the vocabulary, then you're not going to understand the material, right? But aside from that, there are algebraic processes that you're going to learn in these higher level courses that depend on this notation, right? Because you're going to have to substitute in, but specifically only if it's a function. If it's not a function, those techniques wouldn't work, right? So very, very important. I don't know if it was in this class or the other class yesterday where I said that this is the most important topic in the entire course, right? And it really is, because this is the one topic that is the beginning of the rest of your mathematical careers, right? Everything else prior to this was just kind of foundation building, solving basic equations and things like that. This is the beginning, all right? This is, Algebra 1 starts here, all right? Because everything prior to this was pretty much review in some capacity or another, all right? So we're gonna build off of this concept throughout the remainder of this course, and then you're never gonna get away from this. It's always gonna be there, all right? You'll take a little break from it in geometry, but you're gonna come back to it big time in Algebra 2, all right? So in number 2, it says h of b. It doesn't, f of x, h of b, it's all the same thing. It's function notation. So it's saying that we have a function h that's defined in terms of the variable b. Now, I don't know what h and b represent. You know, like it could be home sales for h, and b could be buying power or something like that. It really doesn't matter. If it's in that form, it's a function, right? But all this is telling us to do is replace every b with a -3. So each of them. And then simplify. All right. Now, once you have your setup, it does not matter to me which technique you use. It could be a complete calculator approach. The calculator understands order of operations. It also understands function notation, which I'll get to in a minute, as soon as I can get my calculator up. It just doesn't want to calculate. There it is. I don't want the floating one. No, we don't need that. All right, so all I have to do is type it in the way I see it, just the right-hand side. So 3 times -3 squared minus 2 times -3 plus 1, 34. All right, so you don't have to actually show the work. In the last one, it was simple enough that I didn't need a calculator for it, but this one, maybe you want to. Maybe you want to do it by hand, maybe you want to do it in the calculator to check it. All right. Now the one after that says find g of 2w, right? So that's a little bit different, but it's really the same concept because you're replacing the x with a 2w. Right, so, and then after this, I'll show you some calculator techniques that can kind of streamline this pretty significantly. Everywhere I have an x, bless you, I'm replacing my x's with 2w's. So I rewrite the function with open parentheses everywhere I have an x, at least at first. And for me, it's just a subtle reminder of where I'm making my substitutions. And then I pop in the 2w everywhere. On the left-hand side, it's just a notation. It's saying, what is the function g when x is equal to 2w? So that's done. The right-hand side, I need to simplify out. 2w squared, 2 squared is 4. W squared is w squared. -2 times 2w, -4w, plus 1. All right, so it's a symbolic answer rather than a straight numerical answer, but it's still an answer. All right, and again, it's the result of g of 2w, not g times 2w. All right. Now the last one here is saying f of x is equal to -4x minus 10, and then they tell us that f of n is equal to 14. All right, so let's start with that piece of information, f of n. So I'm going to rewrite my function f of x, replacing every x with an n. All right, so I rewrite the function, open set of parentheses for every x. This is telling me, well, it should have been f of x. Instead of an x in the parentheses, I have an n. So let's just follow that through. Everywhere I should have an x, I will have an n now. And they're telling us that f of n is equal to 14. So this value here, f of n, is 14. The right-hand side is negative 4n minus 10. They're asking for the value of n, so I just have to solve this equation. All right, so I'm just going to add to both sides. And then divide. So we're looking at n equals negative 6. All right, so that's not terrible, but again, if you don't know the notation, then you can't even get started. But let me show you the calculator technique to evaluate functions. I'll just go back to number 2. You can also use a calculator to solve equations, but and folks, this is so important that normally I would say I'll show you a calculator technique and you can decide yourself if you want to use it. This is not one of those situations. I think everybody needs to pay attention to this one. So if you're one of those folks that likes to kind of bypass the instruction to get a jump start on the assignment, I would say sit tight, just watch this the one time, and I think you'll appreciate it. All right, so number 2, it was in terms of b, but there's no reason why it can't be in terms of x. So I'm going to think of it as, and I'll write this step out, but you don't have to write it. I'm just doing it for notes. So think of as h of x equals 3x squared minus 2x plus 1 when x is equal to negative 3. All right. So what you can do is type your function into your calculator into the y equals menu. All right. So again, whether it's h of x, f of x, q of x, it doesn't make a difference. It's all y equals. All right. That notation on the left-hand side is just defining that y as a function. The right-hand side is what goes in. So I type in 3x squared minus 2x plus 1. Now you could use the table approach to figure out the y that corresponds with this x. I'm not going to recommend that because who's to say that the value that you're going to plug in for x is going to be an integer value? It could be a decimal, it could be some irrational number. So if that's the case, then the table's not going to really help you too much. So once you type your function in, quit out of here. All right. So you're in the home screen. What you're going to do is hit alpha trace. So alpha trace and then select Y1. All right, so the trace is right next to graph. So alpha followed by trace, it'll bring up a list of y's, y1 through y whatever, y0 I think. It'll bring up y1 in your home screen. If you open parentheses and then type in the negative 3, the calculator understands function notation. So y1 of negative 3, the calculator knows, and again, this is alpha trace. Alpha trace y1. The calculator knows that this means to evaluate whatever you have stored in y1 for when x is equal to -3. So you hit enter, and it'll compute that number for you instantaneously. All right. The benefit again of this approach is that if I wanted to evaluate my function for 3.2, 3.87, pi squared, right? E, which is also another pi-like number. Anything crazy, like 1 over the square root of 17. The calculator can do that for us instantaneously, right? Whereas in the table, it's not going to work as easily, and also by hand, it could just be a nightmare, right? And also, this is really a way of getting you a graphical solution without actually having to create the graph. Because I could look at the picture for this. All right, cool, it's a parabola. U-shaped curve, nice. But at -3, and I'll show you, the x value of -3, based on my scale here, which goes 0 to 100, -3 is somewhere, well, we know it's in the 30s, it's 34. Am I going to easily be able to pick that out off of a graph? Probably not. So I don't think that this is a situation where I'd want to actually produce a graph just to identify the y value that goes along with it. Right? So just by typing the function in y1, and then in my home screen typing y1 of whatever the x value is, I get the answer like that. All right. Another thing that we'll deal with down the line is that the calculator can solve these equations for you also. So when they tell you what the function is equal to, it can compute that n value. But I'm going to hold off on that because I think it's easy enough to do by hand now because it's all linear functions. When we get to the funkier types of functions down the line, polynomial functions, then I'll definitely show you how to do it on the calculator. But for now, like it's just adding and dividing. Like we haven't learned how to factor yet, but when we do that, that makes things a lot more challenging, and that's where the calculator is going to be really beneficial. All right.